Yeah. Yeah, I hear what you're saying.
Yeah.
We'll probably have to put up some like actual walls, studs and drywall.
Stud walls.
Some nice organization, something for the 3D printer.
Don't forget electrical.
Yep, absolutely that too. And we'll put some shelves over there. We'll have some, maybe some cabinets there.
Can we keep my gym?
Yeah, we'll keep the gym for sure. I know how much you like to work out. And yeah, we'll just get the place looking really cool.
Mm-hmm.
But yeah, that'll be nice. What's that? What is that?
Oh, that? Yeah, that's for your friend. Remember, it's an old AM radio from 1946. Check it out, it's kind of cool.
Philco. Was this thing portable?
Mm-hmm. Yeah, and you could also plug it into a wall.
Cool.
It was his grandfather's.
What am I supposed to do with it? Thinking it's some kind of a time machine?
It's a family heirloom. I think he wanted you to restore it, but don't you think you should do more than just sit on a shelf?
Nothing uses AM frequencies anymore. Is it even worth making it work the way it used to?
What if you modernized it?
We might get some hate from the purists out there, but about a solid state mini amp?
2.1 channel. Give it some range.
Yeah. Gonna need a couple of small tweeters, maybe a 5 or 6 inch subwoofer.
Don't forget a power supply.
I think we should keep that the way that this was originally designed and make it plug in and portable.
Right, yeah. Okay, how about the controller? Bluetooth?
Yeah, maybe. Are you thinking what I'm thinking?
Always. And you don't know how to code.
Oh, come on. I can so code. Alright, fine. That's what I have you for.
No.
Dude, she's baked like right into her script. It'll be easy.
Nope, I'm not messing with that penguin again.
Throw it on a Raspberry Pi. That way we can piggyback with a Bluetooth connection to control music and stuff.
I do love pie.
That's the spirit. Okay, so we're gonna put Alexa up on this thing. Let's just make it an awesome home entertainment device, right? Cool.
The accustomed shock of soft steel met by tool steel helped to counter the shock men had inside them. Other workers slid bolts into slots, not with a slap, but slowly, and tightened down nuts, not with a slash of the wrench, but studiously, as if for the first time.
I went and did some research on this radio. So it's 75 years old, and there is a lot going on in here. It's got to receive broadcasts, amplify the radio and intermediate frequencies. It's got to filter and condition these signals, generate tones, and then drive the speaker. Not to mention handling AC and DC current.
Cool.
Everything is controlled by these 6 vacuum tubes instead of our modern day transistors. So I'm guessing I can take this whole main chassis out and just leave the wood cabinet, and then we can build in from there.
Ignorance, sheer ignorance, there's no confidence to equal it. It's only when you know something about a profession, I think that you're timid or careful.
So even though circuit boards were invented by Paul Eisler 10 years prior to this radio being made, they didn't become mainstream in manufacturing until the 50s, so you're left with this rat's nest of components and solder. It's amazing to believe this was all done by hand. I heard that this was a pretty high quality radio in its day, and they were extremely popular because of their portability and just how reliable they were. Amazing. Now something I definitely want to reuse are these dials here, because I want to keep these same dials in the front of the radio. That way I can use one of these for volume and one of these for off, on. Check it out. Here's what's left inside. It's got this nice metal mesh, and this is actually the antenna. So it was an internal loop antenna, so it goes all the way around where this kind of tape is. The next thing I'm going to do is get this leather strap taken off. I think I'll have to remove these brass footings right here. But yeah, I can replace that with a new strap. I think I am going to take some restoring compound onto this wood, just kind of get some of these blemishes off and some of the old buildups off. Kind of make it look, nice, presentable again. New strap, nice clean wood. Yeah, I think that's going to look good. All right. Can we just get to the part where I have the strap installed, please? Dude, you are so lazy. Go ahead. All right. There we go. All right. That part's done. Now that the exterior is all prettied up, we can get inside and we can start adding in all of our new stuff. You ready with your code? Yep. I'm waiting on you. All right.
I'm ready with all my hardware. Let's do it.
And I didn't know that there were things you couldn't do. So anything I could think up in my dreams, I attempted.
Okay, Hackerjack, so we are using this Raspberry Pi 4 to control everything. How did it go getting Alexa put on here? Yeah, so I was able to successfully compile the sample app with the script provided by Alexa voice service. Whoa. Okay, how long is this going to take? I don't know, it took me like 3 months of research and trial and error and, getting stuff set up and fixing problems. 3 months? Okay, look, you have 2 minutes. Just give people the highlights. No one wants to hear about all of that nonsense. Dude, do you have any idea what I went through to make this work? I had to start over so many times. Just tons of late nights, countless hours talking to my Linux guy in a TMUX session with Ngrok.
Wait, you have a Linux guy?
Yeah, he's a friend of mine. Dude named Mike. It's cool.
But you have friends. You know you're imaginary, right? Imaginary characters don't have friends.
Yeah, well, I do. And he's wicked good with Linux.
Huh. Okay, well, now you have 90 seconds. Go!
Right. Okay, so all of the links to the processes I used are going to be in the description of this video, and I'm going to include them in an instructables write-up so they can follow along and put Alexa on a Raspberry Pi if they want to as well. Also, this should never be done on a Raspberry Pi 0W. I tried that to begin with. I know it's a cheaper option, but don't do it. There's just not enough processing power on that thing. Go with the Raspberry Pi 3 or 4. Okay, so starting off, I got the Raspbian OS on this micro SD card. And you hook it up to a monitor and keyboard and mouse, and you get the Wi-Fi set up, and then you get all the right updates needed and get the initial setup started. And then what I did is I went through Secure Shell or SSH so I could use my computer to control this thing and not have to hook up all the peripherals. You have to start off by setting up an Amazon developer account, and then you create a profile for a new device. I called this one Philco Alexa since it's a Philco radio. So you fill out all of the forms on that page, and then you create a security profile for your device. And once you have that created, you can export it as a config.json file. And then you put that onto the Raspberry Pi. Once you have that done, you can initialize the setup script on the Amazon developer site. Once that finishes, you have to authorize Alexa on the Raspberry Pi running a start sample script. And then once that's authorized, you use that same script to start Alexa. From there, I created a systemd service so that the Alexa will start up whenever power and Wi-Fi are applied to the Raspberry Pi. So it'll just start up in the background without having to run a start script every time. So after that, I set up the Bluetooth as an audio sync so that it can receive audio from a phone. I also had to go in and set up the audio handling so it can receive input from a microphone and then output audio into a speaker. The Alexa app can also talk to the Raspberry Pi through Alexa directly. So using the app, you can do things like stream radio or play music with any subscription streaming services. There are a few tricks here and there that I had to use to solve a problem or make this thing work a little bit better. So I'm going to include all of those in the write-up that I do in the description as well. So yeah, it's all set up. All you have to do is plug in a microphone and a speaker output, and it'll be good to go.
Wow. Okay. Thanks, Hackerjack. I'm going to talk about hardware now. This is the fun stuff, okay?
Hey, some people think code is fun. Alright, here's the plan, starting with power. So first we have the USB-C power bank. This is going to be the main battery that makes this whole thing portable. We have a USB-C to Type-C cable. That's going to connect the power bank to this little circuit board. This is a USB-C power delivery board. This negotiates the 5 volts coming out of the power bank. In the green LED setting, it's going to negotiate 5 volts up to 12 volts. I also want to have a wall plug, so when it's sitting in its home most of the time, it's going to be plugged into a wall with this adapter. So we have 12 volts coming out of the power bank, 12 volts coming out of the wall. Both of those are going to feed into the amplifier on this back port here. Now, since we have 2 power supplies coming into this amplifier, I'm going to use a couple of diodes to make sure that nothing gets confused and the current all flows the right direction. But we also need 5 volts coming into the Raspberry Pi through this USB-C port. So what I need to do is take the 12 volts coming out of the amplifier and step it down to 5 volts with this. This is a 12 volt to 5 volt USB-C buck converter. So 12 volts through here, then out we'll have 5 volts through this USB-C port. So that's the power system. So then we'll go to the back of the amplifier. We have some speakers lined up here. Power goes in, speakers all across here. We have our subwoofer going right here. These are some RCA inputs. For the main tweeters, I just have a couple of laptop speakers. These came out of an old laptop. They're very nice sounding. They're better than any other tweeters that I've seen, so I'm going to go with these. I decided to go with a 4-inch subwoofer to save some space. This has a really nice sound. It fits really well with this amplifier. So that's the speaker side of things. For the audio input now. So obviously we're going to have sound coming from Alexa off the Raspberry Pi. The Raspberry Pi does have its own aux port, but the digital to audio converter, the DAC, on this thing is kind of weak. So what I decided to go with is a external USB DAC. This is going to plug right in here into the USB, and then we can run a aux cable from that into the amplifier. That's going to make for a much more clean, full sound. We're going to be having Bluetooth sound coming through the Raspberry Pi as well as Alexa. And then through Alexa, obviously, like you said, we can control with the Alexa app and run radio or run other music through it. So the Raspberry Pi does need a microphone to talk to Alexa, like you said. So we have this little tiny USB microphone, and that's going to plug in on the very top. I'll just have to figure out a good placement inside the radio for this microphone so that it can be heard from a decent distance away. All right, lots to get done. Let's go. So I want to actually cut the top of this chassis off entirely. I can keep the same mounting points for those dials, and I can also use the same bolt mounting points on the inside of the cabinet. That way things are kind of going to be nice and clean and secure, most importantly. This internal mesh screen goes right in front of the radio and hooks into the main posts. So what I'm going to do for the speakers is have this thin piece of wood that I'm going to screw the mesh into, and then we're going to screw the speakers into the wood itself. So I'm going to have to make some cutouts for the speaker, and then this will be sort of like a mounting plate for the speakers. Okay, and then to get it fastened onto the front mesh here, I think I'm just going to use rivets. So that's going to be what sits inside right behind that front screen there. Cool. Okay, so I want to use the original dials from this radio to control the on-off power switch, and I want to use this one as a volume control. So that I'm actually going to need to unmount the existing power switch and volume knob on this amplifier. I'll have to desolder them and wire them up to their respective dials here. And this switch, I'm going to take that out completely and just use the switching mechanism in this potentiometer. Alright, check it out. I've got the amplifier modded so that I have the rotary switch attached, and I've got the volume knob extended. So that bit's done. I've also got the main chassis rail part here attached to the amplifier case. So I'm going to use some of this epoxy putty. I'm going to basically just epoxy it right onto the rail, and then I'm going to just use the original dial, not the entire assembly, just the dial part, and fasten it to the knob so that, you turn this and it's just turning this part directly. There's not going to be any sort of coupling to it. We're just going to epoxy the heck out of it. So at the same time, we can also just slide the circuit board right back in. Nice. And we can also put in our switch on the other side here. Cool. Happy with that. We've got our volume knob attached over here, and our power switch is now right there. We're going to start working on the power system now, so we're going to start by just soldering wires onto my power delivery board. I'm going to solder a diode into that line. Okay, lots more to solder. This plug is actually going to plug into the back of the amplifier, so it's going to have to join up with these other two sources coming in. We have battery, wall plug, into the amplifier. And then we also have coming out of that the buck converter that's going to go into the Raspberry Pi. Okay, so we've got all of our red wires and lined up and twist. Same with our blacks. I'm gonna throw some solder on all these joints here. So we've got everything soldered up, all the current flowing the right way. Let's get these ends protected here so there's no shorts. We tie a knot like this in the heat shrink itself. There. Slide that over. There we go. Slide it on. There we go. Easy day. Alright, there we have it. A little mess of a power harness, but everything seems to be working the way it should. Cool. What's next?
You got away with enormous technical advances, didn't you?
Simply by not knowing that they were impossible. Or theoretically impossible.
Alright, everything's ready to go. All of the pieces are in place. Time for the build montage.
He, like all great men, I think, who are masters of a craft, told me right at the outset that there was nothing that I couldn't learn in half a day, that any intelligent person couldn't learn in half a day. And he was right.
Alexa, are you there?
I'm here. I listen once I hear the wake word.
Alexa, tell me a joke.
Sometimes I wonder what it would be like to be an accountant. I'm sure it has its pluses and minuses.
I hope you enjoyed this video. Thank you so much for watching. In the description, I will have a full write-up, including diagrams and parts lists if you want to attempt something like this on your own. Hey man, I'm doing the outro. Get out of here. Oh, fine. But hey, don't forget the audio.com. I'm not going to forget the audio.com. Shoot. All of the music in this video was licensed through audio.com. I'm an affiliate of theirs, and right now they're offering $100 off their lifetime music membership with the code SAVE100. If you're a video creator or you do anything that requires licensing music, audio.com is perfect because they have a massive music library. And instead of paying monthly or yearly, like you do with most other licensing services, you pay once, forever. Use the link in the description to find out more about audio.com. Well, there we have it. we turned the 75-year-old radio into a modern entertainment system. It sounds really good and has all of the smart features of any modern audio system. And I love the classic aesthetic hasn't changed despite all of the upgraded internals. I'm really pleased with how this turned out, and I think my friend's going to be as well when I give this back to him. Anyways, thank you all so much for watching this video. We will see you in the next project. Bye for now.